Hello, good afternoon, students. Good afternoon. Am I audible and visible? Please tell me. बच्चों बताइए, how am I audible and visible? ईशन कुमार, good afternoon. एक बार बता दीजिए बेटा, is it audible and visible? Am I clear? Yes, very good. India won the World Cup. Congratulations to you also. बच्चों बताइए please, can we start? Give me the clearance. Can we start? Give me the clearance. Okay, very good, very good. It's all clear. Thank you so much. Thank you. Gajendra Singh Sisodia and other people, good afternoon again, very clear. So very good afternoon to all of you. Welcome to Unacademy. Dr. Khalil Khan here. और हम नया आगाज सीरीज का नेक्स्ट लेक्चर लेने वाले हैं ऑपरेटिंग सिस्टम का, और टॉपिक ऑफ डिस्कशन वन ऑफ द वेरी वेरी इंपॉर्टेंट टॉपिक इन ऑपरेटिंग सिस्टम, और वो है सेमाफोर्स. तो चलिए बच्चों, विदाउट ए वेट लेट अस बिगिन आवर डिस्कशन आज के टॉपिक का. दिस इज माय टेलीग्राम चैनल एज यूजुअल. तो यहाँ पर हम स्टार्ट करेंगे. Semaphores. So it is essentially a blocking mechanism, but initially it was implemented in busy waiting mode also. वो भी हम डिस्कस करेंगे. But essentially जो फाइनली जो उसका इम्प्लीमेंटेशन है इन ऑपरेटिंग सिस्टम्स, इट इज ए ब्लॉकिंग कंस्ट्रक्ट. इट इज इम्प्लीमेंटेड इन द ब्लॉकिंग कंस्ट्रक्ट. Vaibhav Singh, you can get the complete schedule on the WhatsApp, on the Unacademy channel or Unacademy app. You can get the complete schedule, वहाँ पे मिल जाएगा आपको. तो चलिए कंटिन्यू करेंगे. इट्स अ ब्लॉकिंग मैकेनिज्म and let me write important highlights of this. It is OS based primitive. It is not a software or hardware solution, but rather it is implemented in operating system. ये operating system के kernel में implement होगा as an important resource, software resource की तरह use होगा. It is implemented as a software resource, and it is a general purpose utility. It's a general purpose utility. ये मेरा अपना own term है. You won't find this as such in the textbook. इसका मतलब क्या है मैं आपको बताऊंगा. जनरली जो भी मैकेनिज्म्स अब तक जो हमने देखा है, जैसा कि है पीटरसन सोल्यूशन, डेकर एल्गोरिथम, टीएसएल, एंड यस्टरडेज क्लास जो हमने देखा था टीएसएल सोल्यूशन, एंड देन वी सॉ कंपेयर एंड स्वैप. ये जितने भी सॉल्यूशंस है, दे आर एसेंशियली और प्राइमरीली मेंट फॉर सॉल्विंग द प्रॉब्लम ऑफ क्रिटिकल सेक्शन. लेकिन सेमाफोर की ब्यूटी ये है, द ब्यूटीफुल कॉन्सेप्ट ऑफ सेमाफोर इज दैट it is used not only for solving the problem of critical section, but also meet the synchronization requirements of many other problems. It is also used in concurrency or as a concurrency mechanism to solve many concurrency based problems. So that way it is a general purpose utility. So that is one of the important aspect of this. So, and then this was proposed by a famous eminent person of computer science, computer professor by name 𝐂𝐤𝐬𝐿. The same person 𝐂𝐤𝐬 who proposed the shortest path algorithm or shortest path problem, single source shortest path का जो algorithm है, famous algorithm है 𝐂𝐤𝐬's algorithm. That same person, the first recipient of the Alan Turing Covetus or very prestigious computer science का जो award है, Turing Award, that was proposed by 𝐂𝐤𝐬𝐿, same person. ठीक है. And essentially it is implemented. semaphore is implemented as an ADT, abstract data type. जब आप उसका implementation देखोगे semaphore का, तो essentially it is implemented like an abstract data type. And as you know, being an abstract data type, it will support some operations. It will have its representation, it will have its definition, and it will have some attributes. So therefore it will, yeah, Ishan, we will discuss at the end of the class ke kab roughly support hoga, right? Kab complete hoga, we'll discuss. So being an abstract data type, it support a well-defined list of operations. जैसे कि for example आपने पढ़ा होगा data structure में, when you implement stack as an abstract data type will support operations, queue as a data type will support operations, linked list as a data type will support operations. तो उसी तरह semaphore when it become implemented, उस तो concept तो एक है, when it become implemented, right, it is implemented as an abstract data type supporting operations. तो कौन से operations है semaphore के? What are the semaphore operations? Semaphore support two operations. Please remember, semaphore support two operations. One by name down, other by name up. Other by name up. Down operation is also called wait, and up operation is also called signal. It is also called P operation, and it is also called V operation. There are three different types or notations that semaphore operations. So don't think that there are 6 operations, only 2 operations. Either you say down or up, या फिर आप बोलो wait and signal, या आप कह सकते हो P and V. So it support only 2 operations. This person 𝐂𝐸𝐴 was basically a Dutch scientist, Netherlands Dutch. तो उनकी जो Dutch language है वहां पर एक वर्ड है प्रेसरेंट जिसका मतलब है डाउन, डिक्रीमेंट करना. तो 𝐂𝐸𝐴 took the first letter of the word and call it as P. And up operation, it is basically known as verhogen in Dutch, and that means increment up. So he took the first letter of the word P and V. So initially 𝐂𝐸𝐴 named the semaphore operations as P and V. Later उसका नाम चेंज किया गया down and up, and most popularly जो टेक्स्ट बुक में या फिर आप और अदर रिसोर्सेस में देखोगे, they will call the semaphore operations as popularly wait and signal. And let me add, some people even call signal operation as release. I am telling you all conventions, जितने भी conventions गेट एग्जाम के पेपर में यूज हुए हैं या कोई लिटरेचर में हो, these are the different conventions. These are different conventions. तो ये है semaphore operations. Important part is the semaphore operations are atomic. Semaphore operations are atomic. ये बहुत ज्यादा important point है आपको remember करने के लिए. Why? Because it is implemented in operating system kernel, and anything which is implemented as a kernel resource, it is always atomic. वो हमेशा atomic रहेगी. So point to be kept in mind always is semaphore operations are atomic. मतलब जब भी कोई प्रोसेस डाउन ऑपरेशन एग्जीक्यूट करेगा या अप ऑपरेशन एग्जीक्यूट करेगा, इट विल नेवर गेट प्रीएम्प्टेड. काफी इंपॉर्टेंट पॉइंट है बच्चों. Whenever a process execute down operation या up operation, it will never get preempted from CPU. The whole down operation will be carried out successfully without any preemption. The whole up operation will be carried out successfully without any preemption. ठीक है? So down operation complete करने के बाद when you shift the mode from kernel back to user, उसके बाद जब preemption हो सकता है, उसके बाद preemption हो सकता है, because it is implemented in kernel. Most often in most of the operating system, these down and up operations are implemented like system calls. They are implemented like system calls. Like in Unix you take, it is implemented in the form of a system call. जैसे fork system call है, उसी तरह these operations are also implemented like system calls. So kindly remember that. That's again a very important point. ठीक है? So important points मैंने यहाँ पे लिख दिया है. Semaphore operations are atomic, and they are generally implemented as system calls in practice in many of the operating systems. ठीक है? तो हमारा जो मेन डिस्कशन है सेमाफोर के बारे में वो है अंडरस्टैंडिंग सेमाफोर ऑपरेशंस. दैट इज द मेन क्राइटेरिया. वहीं पे बच्चों को बहुत ज्यादा स्ट्रगल होता है. दे डोंट अंडरस्टैंड सेमाफोर ऑपरेशंस क्लियरली, एंड आई विल ट्राई माय लेवल बेस्ट टू एक्सप्लेन टू द मैक्सिमम कोर. ठीक है? एंड यू ट्राई टू पे अटेंशन एंड ट्राई टू बेनिफिट आउट ऑफ दिस सेशन बाय अंडरस्टैंडिंग सेमाफोर ऑपरेशंस. ठीक है? अगर जब आप सेमाफोर ऑपरेशंस अच्छे तरीके से समझ लोगे, व्हेन यू अंडरस्टैंड सेमाफोर ऑपरेशंस very clearly, then I'm very sure you can be in a position to work out any question. कोई भी आप क्वेश्चन आराम से कर सकते हो, provided you get a firm grip of semaphore operations. ठीक है? And let me tell you one more historical perspective कि सर ये नाम तो बड़ा अच्छा दिख रहा है प्रोनाउंस करने के लिए semaphore, इसका मतलब क्या है? What does it mean? तो I will tell you the historical perspective. Generally ये word जो है semaphore, it is used in the signaling process, signaling for signaling purpose in navy systems. जब ships जाते हैं, so if one ship want to communicate with the port or communicate with another ship, the signaling system which is used, that is called semaphores. या आप अगर और हिस्ट्री में इसकी हिस्ट्री देखना चाह रहे हो, इसके बारे में जानना चाह रहे हो, तो आप गूगल में सर्च कर सकते हो semaphore signaling system used in navy systems. They will display all the symbols also for which are used for different signals, different signaling. तो semaphore का मतलब signaling. तो उसी बेसिस पर ये ऑपरेशन है सिग्नल ऑपरेशन. ठीक है? तो दैट इज द हिस्टोरिकल पर्सपेक्टिव ऑफ द वर्ड सेमाफोर व्हिच इज कॉइन्ड बाय. हाँ विजय, कुछ क्वेश्चन भी सॉल्व करूंगा मैं सेमाफोर के बेसिस पर. नेक्स्ट सेशन में और ज्यादा क्लासिकल आईपीसी प्रॉब्लम जब होंगे तो वहां पर ज्यादा एप्लीकेशन देखेंगे हम सेमाफोर ऑपरेशंस. सिंपल डायरेक्ट प्रॉब्लम भी सॉल्व करेंगे, कुछ पीवाईक्यूज भी देखेंगे, एंड देन क्लासिकल आईपीसी प्रॉब्लम्स में और ज्यादा एप्लीकेशंस हम देखेंगे ऑन सेमाफोर. हाँ, रेलवेज ऑल्सो आई थिंक दे यूज द सेम टर्म सेमाफोर्स, सिग्नलिंग मैकेनिज्म. जनरली सेमाफोर वर्ड जो यूज होता है वो नेवी सिस्टम में यूज होता है, इन नेवी सिस्टम. चलिए आगे बढ़ेंगे बच्चों, बिकॉज इंपॉर्टेंट थिंग इज दिस. तो डेफिनेशन बाय व्हाट इज द मेन डेफिनेशन ऑफ सेमाफोर. सेमाफोर का डेफिनेशन यहां पर फॉर्मली लिखने की कोशिश करेंगे, एंड बेस्ड ऑन द डेफिनेशन वी विल क्लासिफाई द सेमाफोर टाइप. सो लेट्स राइट द डेफिनेशन. Definition of semaphore. Semaphore is a variable, so let me write fully, otherwise. Semaphore is a variable. जब भी कोई वेरिएबल डिक्लेयर करोगे आप, whenever you define any variable, तो देखो बेटा, वेरिएबल should always be of some type. आप बोलोगे इंटीजर टाइप, कैरेक्टर टाइप, फ्लोट टाइप, बुलियन टाइप, कुछ ना कुछ टाइप होगा, या फिर यूजर डिफाइंड टाइप, या फिर यूजर डिफाइंड टाइप. एनी वेरिएबल should be of some type, whether in most of the time in static languages. Dynamic languages की बात अलग है, हम वो डिस्कस नहीं करेंगे, because you are all familiar with C language. That's what I'm saying. C is like a statically typed language most often. तो वहां पर आप जब वेरिएबल डिफाइन करोगे, that will always be of some type. ऐसा नहीं है कि एक वेरिएबल आप रैंडमली कुछ भी डिफाइन कर दो ऑफ एनी टाइप, ऐसा नहीं है. इट शुड बिलोंग टू सम टाइप, आइदर यूजर डिफाइंड टाइप और प्री डिफाइंड टाइप. तो सेमाफोर इज अ वेरिएबल. जब हम वेरिएबल कह रहे हैं तो वेरिएबल ऑफ व्हाट टाइप? वेरिएबल ऑफ एडीटी, एब्स्ट्रैक्ट डेटा टाइप. ये एब्स्ट्रैक्ट डेटा टाइप इट इज लाइक ए डेटा टाइप, इट इज लाइक ए टाइप वेरिएबल, एब्स्ट्रैक्ट डेटा टाइप, जिसका नाम हमारे कन्वेंशन से हम रखेंगे सेम. एक नाम देना होगा डेटा टाइप का. Let us say from our side, abstract data type का नाम है sem. So semaphore is a variable of abstract data type by name sem, with the property that variable that variable takes only integral values. It takes only integral values. Semaphore is a variable of abstract data type by name sem, with the property that it takes only integer values. Integral values का मतलब है only integer values. It cannot take any real value, it cannot take any float value, it cannot take any boolean, complex value or anything. Only integral values. Integral का मतलब integer. The point is, based on the values, next page पर हम जाएंगे. Now based on the value that the semaphore take, based on the value or based on values, semaphores are classified into two types. There are two types of semaphore. बताइएगा मुझे chat box में please, what are the two types of semaphore? Anybody? Semaphores based on the value are classified into two types. क्या कोई बताएगा मुझे chat box में what are the types of values the semaphore, what are the types of semaphore? Anybody? What are the two types of semaphore based on the value? Excellent. One is binary and the other is counting. Counting semaphore is also called general semaphore. is also called general semaphore. Binary, as the name implies, binary जैसा नाम बता रहा है, can take only two values. Binary semaphore can take only two values, either 0 or 1. Either 0 or 1. And counting semaphore can theoretically take values from minus infinity to plus infinity. Minus infinity to plus infinity. मतलब any positive value or any negative value semaphore, counting semaphore can take. Since binary semaphore की जो value है 0, 1, binary semaphore की जो value है 0, 1, it is a subset of this value of counting semaphore. That's why we say binary is a subset of counting. तो मतलब ये है कि whatever applications you can implement with binary can also be implemented with counting, because binary की जो value है वो it is a subset of counting. And अगर आप पूछो कि सर क्या कोई advantage है, क्या कोई is there any advantage of binary semaphore over counting or counting over binary? There is nothing like that. There is nothing like that. There is nothing like any advantage or drawback of binary over counting or counting over binary. ऐसा कुछ नहीं है, ठीक है? So some operating systems may go for implementation of binary, and using binary you can implement counting, and some operating system they can implement only counting because binary is a part of it. So nothing like any benefit or advantage. Of course, with counting semaphores you can directly use the semaphore operations to meet the requirements of synchronization conditions, and we will see them in the case of classical IPC problem, जहां पर हम देखेंगे producer consumer problem, reader writer problem, dining philosopher problem, वो how these problems are actually implemented, कैसे implement होंगे using binary and counting semaphore. That will be an interesting exercise. तो बच्चों सबसे पहले हमें डिस्कस करना होगा about this counting and binary semaphore. तो फर्स्ट आई वुड प्रेजेंट टू यू, जैसा मैंने कहा, the semaphores basically are implemented in two ways. Semaphore implementation. Semaphore implementation in two ways. What are the two ways? So let me write here. One is implemented as busy waiting. ये primitive approach है, ये old approach है, and the other is blocking, and this is the default one which is also used in many contemporary operating systems. These are default. तो but as a matter of fact busy waiting में कैसे implement होगा वो हम यहाँ पर देखेंगे. Busy waiting, this is old approach, primitive approach. तो दोनों भी मैं आपको बताऊंगा. I will show you both how it can be implemented in primitive way and how it can be implemented in non-primitive way. तो पहले यहां पर देख लीजिएगा प्लीज. आई एम शोइंग यू द इंप्लीमेंटेशन ऑफ semaphore as a busy waiting construct. So it is a synchronization tool that provides more sophisticated, advanced than mutex locks. Mutex locks बाद में हम देखेंगे for processes to synchronize their activities. Semaphore S हमने कहा like for this is a busy waiting construct. ये जो implementation है इस पेज पर वो है busy waiting implementation. busy waiting implementation, ठीक है? तो semaphore का जो नाम दे रहे हैं वो S है. It is like integer variable in the sense can hold integer value, can only be accessed by two indivisible or atomic. अभी मैंने कहा semaphore operations are always atomic. Semaphore operations, one by name wait, another by name signal. Originally called, मैंने कहा था, Dijkstra named the semaphore operations as P and V. The definition of the wait operation is here. Let me underline. Let me highlight this. Let me highlight, boys and girls, please see. The definition of wait operation is here. Let me underline. फिर उसके बाद हम अंडरस्टैंड करने की कोशिश करेंगे. सबसे पहले मैं आपको सिमेंटिक्स बता दूं ऑफ द वेट ऑपरेशन. सिमेंटिक का मतलब है मीनिंग. व्हाट हैपेंस जब भी कोई प्रोसेस परफॉर्म करेगा वेट ऑपरेशन. लाइक फॉर एग्जांपल इन माय एप्लीकेशन, ये मेरा यूजर एप्लीकेशन है. प्लीज फॉलो केयरफुली. If this is my user application, maybe like your C program, I have defined semaphore as S. So I will define like integer variable S. Yeah, as I said, the semaphore variable, semaphore type, we are type defining semaphore integer as sem S. So S is a variable of semaphore type. S is a variable of semaphore type with the characteristic that it can take only integer values. And before performing the semaphore operations, ये बात याद रख लीजिएगा हमेशा, very important point. Before performing semaphore operations, before performing or carrying out semaphore operations, semaphore must be initialized. जरूरी है कि semaphore की वैल्यू इनिशियलाइज करना है उसी तरह जिस तरह आप स्टैक डिफाइन करो एज एन एब्स्ट्रैक्ट डेटा टाइप, फिर उसके बाद यू विल हैव टू इनिशियलाइज द स्टैक पॉइंटर. अगर आप स्टैक पॉइंटर इनिशियलाइज ना करोगे, यू कैन नॉट परफॉर्म डायरेक्टली द पुश एंड पॉप ऑपरेशंस विदाउट इनिशियलाइजिंग स्टैक पॉइंटर, टॉप पॉइंटर. ठीक है, टॉप ऑफ द स्टैक इनिशियलाइज करे बगैर, generally it is initialized to 0 or maybe 1 depending on the convention of the language, what is array indexing. So top must be initialized before you start performing down and up operations. So likewise, उसी तरह semaphore variable, after declaring or defining the semaphore variable in the application, आपने जरूर उसे initialize करना है. Without initializing, you cannot perform down and up operation. You cannot. Now the question is very important question. Please understand. यहाँ पर आपको difficulty होती है generally student because they don't pay attention. What must be the initial value of semaphore? There is no hard and fast rule that semaphore must be compulsorily should be initialized to 0 or 1 or something. Boys and girls, please remember as a very important point, the initial value of semaphore is governed by the application. जो application आप solve कर रहे हो, right, using semaphore, that application will define के initial value क्या होना चाहिए, क्या होना चाहिए. Like for example, if I am solving the problem of critical section, initial value of semaphore should be 1. If I am solving some other problem where a resource is to be not used by more than 3 processes, semaphore value must be initialized to 3. ये क्यों? We'll understand when we take up the semantics of down operation. तो बच्चों बस इतना याद रखना है, आपको रिमेंबर करना है, अंडरस्टैंड करना है कि आफ्टर डिफाइनिंग द सेमाफोर वेरिएबल यू मस्ट इनिशियलाइज एंड द इनिशियल वैल्यू ऑफ सेमाफोर इज गवर्न्ड बाय द एप्लीकेशन, इज डिसाइडेड बाय द एप्लीकेशन. ना मैं डिसाइड कर सकता हूं ना आप डिसाइड कर सकते हैं. इट इज गवर्न्ड बाय द एप्लीकेशन. सो लेट अस इमेजिन in our application the value of semaphore is initialized to some value, something like 1. Then after initialization you can perform any operation in any order any number of times. These points are very important. You can perform semaphore operations in any order, any time, any number of times. Again governed by the application. आपका application demand करेगा कि किस operation को आपने पहले use करना है. यहां पर हमारा ऑब्जेक्टिव अंडरस्टैंड करना है सेमाफोर ऑपरेशंस को. सो लेट अस से आई एम कैरिंग आउट वेट ऑपरेशन. सो आई विल कॉल लाइक ए सिस्टम कॉल wait on semaphore S, and after that this is my next statement SI something like this. So this is my user application. हमने semaphore define किया, semaphore की value initialize की, फिर उसके बाद हम wait operation perform कर रहे हैं. और wait operation now this will be called like a system call. This will be executed like a system call. तो मतलब यहां पे मोड शिफ्टिंग होगी. You will transit from user mode to kernel mode. You will execute the system call atomically and then the control returns back to user mode and then you start the next statement. ये ऐसा पैराडाइम है. Modality of execution is like this. ठीक है. तो अब हमें अंडरस्टैंड करना है बच्चों कि what happens when a process execute down operation or wait operation. What happens when a process perform down operation or wait operation. So please follow me carefully. This wait is different from the regular wait which you have in this. ठीक है. This wait is different. लेकिन semaphore convention से wait मतलब down. Wait मतलब down. ठीक है. The wait system call जो आप process management में use करोगे, that is different. That is different. Definitely it is different. That is a good point raised by Mohan. The wait system call, there it is used for basically like waiting for the child process to terminate. उसके लिए यूज होगा. ये वेट जो है डाउन है, अलग है. तो सेमाफोर में सेम डॉट वेट बोल के आएगा. तो सो दैट देयर इज नो कंफ्यूजन. डोंट वरी अबाउट इट. तो यहां पर आप वी आर मेंटेनिंग कंसिस्टेंसी ऑफ द सिमेंटिक्स. तो दिस वेट इज नॉट द रेगुलर वेट ऑफ द सिस्टम कॉल. क्लियर, वेरी क्लियर. तो चलिए, आप अगर कंफ्यूजन हो रहा तो वी विल रिमूव दिस एंड राइट डाउन ऑल्सो. देयर इज नो प्रॉब्लम. डाउन और क्योंकि यहाँ पे मैं सिस्टम यहाँ पे वेट लिखा हूं तो इसलिए यहां पर भी वेट लिया हूं. तो चलिए अब देखेंगे वेट. व्हाट हैपेंस व्हेन ए प्रोसेस परफॉर्म वेट ऑपरेशन, व्हाट हैपेंस व्हेन ए प्रोसेस परफॉर्म डाउन ऑपरेशन. प्लीज रिमेंबर बॉयज एंड गर्ल्स, व्हेन ए प्रोसेस परफॉर्म डाउन ऑपरेशन और वेट ऑपरेशन, it will result in either down being successful or block, busy wait, because this is busy waiting, right? This is busy waiting. So the current value of semaphore, see the definition. If the current value, यहां पर देखिएगा while loop है ये. if the current value of semaphore S is less than or equal to 0, अगर current value less than or equal to 0 है, we busy wait. That means we are unsuccessful. We are unsuccessful, therefore we are waiting. We cannot proceed. अब हमें रुकना है यहाँ पर. That's why we say wait. You have to wait. Why? The value is less than or equal to 0. Sir, ये value less than or equal to 0 wait क्यों करना है? Application लेने से समझ में आएगा. Have some patience. These are the norms given by Dijkstra. और वो practically भी है. आप example लेने से समझ में आएगा why it has to wait. So if the resultant value of semaphore is less than or equal to 0, process performing wait operation has to wait. मतलब अगर मैंने value of semaphore 1 है मेरी, सुनिएगा, value of semaphore is 1. When I test the condition fails, so I don't busy wait. I come out and decrement the value of semaphore by 1. ये जो decrementation हो रही है when the condition is false, ये जो decrementation हो रही है, that's why it is called down. Decrement मतलब down. So if the value of semaphore is greater than 0, 1, 2, 3, 4, greater than 0, then I will be successful in performing down. Otherwise, if the value of semaphore is less than or equal to 0, I repeat again, if the value is less than or equal to 0, check, then the process is unsuccessful in performing down and it wait. ठीक है? This is the semantics of down operation. So boys and girls, in short, we say any process performing down operation, any process performing wait operation, its result will either be successful or unsuccessful. Successful का मतलब है it does not get blocked or does not get wait. Successful का मतलब ये है कि it does not get blocked or does not get wait. It will return successfully from down and continue with the next statement after down. Otherwise, if it is unsuccessful, means S is less than or equal to 0, then the process gets blocked, it gets waiting. So result of down is either success or unsuccess. ये हमेशा याद रखिए. When it is successful, if the value of semaphore is greater than 0. When it is unsuccessful, if the value of semaphore is less than or equal to 0. As simple as that. अब जैसा यहाँ पर application में देखिए, if the value of semaphore is 1, if I carry out down, if I carry out this condition will be false. So what do I do? ये while loop यहीं पे end हो रहा है. बच्चों confuse नहीं होना. This while loop is getting terminated here. S equal to S minus 1, decrementing the value of S is outside the while loop. दिख रहा ऐसा है कि while loop की body में है. While loop is getting terminated. Note this semicolon. This is S equal to S minus 1 is outside the while loop. So this will be this statement S equal to S minus 1 will be executed only if the condition is false. मतलब S equal to 1 it will be success. So I come out. Otherwise I will be in the busy wait. This is the meaning of down. उसी तरह अप ऑपरेशन में क्या होगा? दिस इज बिजी वेटिंग बेस्ड सेमाफोर. अप ऑपरेशन में क्या होगा? अप ऑपरेशन इन बिजी वेटिंग, एनी प्रोसेस परफॉर्मिंग. अब like for example here, after wait, if I perform signal operation, if a process perform signal operation on S, check. Any process performing signal operation is very simple. It will simply increment the value of semaphore. Semaphore की जो value है, it will increment it by 1 automatically. It will increment it by 1 atomically, not automatically, I'm sorry, atomically. That means incrementation के दौरान preemption नहीं होगा. It is in kernel mode. Repeatedly I'm saying down and up operations are atomic. They are indivisible. No preemption happens while the process execute down and up operation. Remember. So any process performing up operation will simply increment the value of semaphore by 1. That's it. That's all. This is down and up. तो सर इतने सिंपल ऑपरेशन से क्या हम सेमाफोर का, क्या हम सिंक्रोनाइजेशन के प्रॉब्लम सॉल्व कर सकते हैं? हाँ कर सकते हैं. सर कैसे करेंगे? चलिए एप्लीकेशन लेंगे. Let us solve the critical section problem. Let us solve the critical section problem using non-busy or busy waiting critical section. Let us write solving critical section problem. Solving critical section problem using counting, or it can be treated as binary also. Binary semaphore as a busy waiting tool or a busy waiting mode in बोलिए आप in a busy waiting mode. Busy waiting mode जो अभी हमने down and up operations describe किए हैं, using that let us solve critical section problem. So imagine for example this is my process. This is any process I. Life cycle may be infinite. Life cycle may be infinite. ठीक है? And then I may have initially, let us say, non-critical section. And after non-critical section is over, अब हम entry section design कर रहे हैं. Any process desiring to enter critical section should perform down operation, should perform wait operation. So let us perform wait operation. Dev Akbari. Why do we increase? Ishan Kumar, please have a look. ये application से आपको समझ में आ जाएगा कि why are we incrementing the value of semaphore? ये application से समझ में आ जाएगा. Follow me. That's why I'm taking this example to understand why we are incrementing. So please see here. So any process desiring to perform go into critical section should perform wait operation on semaphore S. So what is S? Semaphore. Semaphore S. What must be the initial value of semaphore? The initial value of semaphore should be 1. Why it should be 1? अभी आपको थोड़ी देर में समझ में आ जाएगा. तो सुनिएगा आप. Wait on S. Then I say we have critical section code. Then after coming out from critical section, the process will perform up operation on S or signal operation on S. You say wait or signal, down and up, anything. Both are interchangeably correct. So this is my entry section. This is my entry section. And this is my exit section. Entry and exit. So let's write. This is entry. This is exit. So how this wait operation and signal or up operation can be used to solve my critical section problem? Bachcho, solving critical section problem means guaranteeing mutual exclusion, progress and bounded wait. So by means of wait and signal operations, how can we solve critical section problem to mean solving for mutual exclusion, progress and bounded wait? Chaliye understand karenge by means of a typical scenario. So imagine, for example, this is ready queue and this is CPU. Follow me carefully. This is CPU. And let us also assume that this is critical section. This critical section. And here I have some processes P1, P2, P3. So this is my semaphore S with its current value 1. Semaphore S with its current value 1. So follow me, boys and girls, very clearly, because it's an important trace to show how semaphore can be used to solve my problem of critical section. So please have a dedicated look at this. This is ready queue. This is a CPU. This is my critical section. Okay? And now follow the code. Imagine for example, process P1 is running on CPU. Completed non-critical section and P1 now perform wait on S. अब आप मुझे बोलिएगा, when P1 is performing wait on S with this implementation of wait on S, जो implementation है wait on S, right? While S is less than or equal to 0. No, S is not less than or equal to 0. S is equal to 1. So condition fails. Condition of the while loop fails. Please observe. Condition of the while loop fails. So what happens? S value is decremented by 1. S value is decremented by 1. मतलब S की value हो जाएगी 0. And process returns successfully. ये success condition है. It returns successfully from wait. तो return होने के बाद क्या करेगा? P1 will go to critical section. Boys and girls, P1 will go to critical section. जब P1 critical section में होगा, तो P2 and P3 other processes, if they want to enter, they shouldn't be allowed. They should not be allowed. जब P1 critical section में होगा, P2 and P3 should not be allowed. देखेंगे how P2 and P3 are not allowed. Imagine P1 running on CPU, executing some part of critical section, got preempted from CPU. Got preempted from CPU. जब preempt होके CPU से जाएगा, तो process P1 will come back to ready queue. And let's imagine we are giving the control to P2. We are giving the control to P2. So P2 क्या करेगा? Look at the condition. Look at the condition, boys and girls. P2 यहाँ पे आएगा. While S is less than or equal to 0. Yes sir, S is less than or equal to 0. Are you getting? S is less than or equal to 0. Current value of semaphore क्या है? 0 है. P2 is seeing a value of 0. तो अब क्या होगा? सुनिए. The value is less than or equal to 0. Yes. So process will not execute this statement. Process cannot execute this statement. यहीं busy wait में फंस जाएगा P2. So P2 keeps on busy waiting till it runs on CPU. It cannot proceed further. P2 cannot execute cannot go into critical section. So how long will it perform busy waiting? Till it get preempted from CPU. जब उसका time quantum शायद खत्म हो जाएगा, then it will leave the CPU. So imagine after some time, P2 completes its time quantum and leave the CPU. come back to ready queue. Come back to ready queue. Next time we run, so therefore we say P2 is in busy waiting mode. I'm putting this symbol to indicate that this is busy waiting. Busy waiting. Now P3 start. P3 start. What is the value of semaphore? Still 0. P3 also see the value of semaphore as 0. Condition of the while loop क्या है? True है, false है? True है sir, less than or equal to 0. So P3 like P2 also perform busy waiting. Like P3 also perform busy, like P2 it also perform busy waiting. Then after some time it get preempted and P3 will also come back to ready queue performing busy waiting. So वही होना है. That is what we want. That is what we want because P1 is there in critical section. So P2 and P3 should not be allowed. We are proving that they are not allowed. We are proving that they are not allowed. फिर इसके बाद क्या होगा? Maybe after some time we give the control to P1. P1 will take the charge. P1 was in critical section. Earlier before its run, where it has basically executed some part of critical section. अब imagine करेंगे हम कि P1 has completed critical section. Let's imagine P1 completed critical section. तो P1 critical section complete करने के बाद क्या करेगा? P1 after completing critical section, what will it do? Yes, exactly. So P1 after completing critical section, it will perform up operation. This is very important. P1 अपना काम कर चुका, so it is supposed to release critical section. तो उसके लिए क्या करेगा? Up operation करेगा. बच्चों up operation में हमने देखा, it is only going to increment the value of semaphore by 1. Check it. It is going to only increment the value of semaphore by 1 and do nothing. Do nothing. So value of semaphore is 1. P1 performing up operation will make the value of semaphore back to 1. Will make the value of semaphore back to 1. तो इससे क्या होगा? इससे अब जो होगा देखिए आप. So let's imagine P1 has left the CPU, completed its operation, and let's say it go back into non-critical section. It go back to non-critical section. अब देखिएगा कौन रन करेगा? Maybe P2 or maybe P3. दोनों प्रोसेस तो एक साथ रन नहीं कर सकते. So maybe either P2 or P3. So let's imagine we are giving the control to P2. So P2 starts or regains the control of CPU. So earlier, if you remember, P2 was basically in the busy waiting. So now again it executes this busy waiting loop. It was there in the busy waiting loop. So therefore again it tests the condition while S is less than or equal to 0. Answer, it is less than or equal to 0. Correct. It is less than or equal to 0. Sorry, the condition is false. Why? Because the value of S is 1. Earlier it was 0, so it was busy waiting. Now when it starts the while loop again, S is less than or equal to 0. No sir, S is 1. Condition fails. फिर क्या करेगा P2? P2 will decrement the value of semaphore again by 1. So it becomes 0. Again it becomes 0 just like P1. So therefore P2 enters critical section and that's how it has to enter. After P1 enter and come out, P2 has to enter. So P2 will enter critical section. P3 का state क्या है? It will be still busy waiting because the value of semaphore is 0. Even if you assume preemption of P2 and P3 regains the control, P3 फिर से देखेगा value of semaphore 0 है. So it will basically be blocked or it will be in busy waiting. So P3 cannot enter. Then finally, when P2 comes out, when P2 can release the critical section, execute the exit section, again basically it will make the value of semaphore to 1 by incrementing, by performing up operation. तब क्या होगा? Maybe P3 will enter, P3 will execute and P3 will enter critical section. So this proves the scenario that when one process is in critical section, other two processes cannot enter with this code or with this implementation of semaphore. So this is proof to guarantee mutual exclusion progress. लेकिन bounded waiting का condition we cannot guarantee. Why? Because जब P2 बाहर आएगा and if P1 wants to enter again, there is a possibility that P1 can re-enter critical section again. So with this busy waiting, implementation of semaphore, bounded waiting may not be guaranteed. तो bounded waiting condition guarantee करने के लिए we have to go for the blocking construct or blocking mechanism of semaphore. So that we will talk about it. So this is a primitive implementation of semaphore operations, we can say, where we are implementing as busy waiting based. So busy waiting का drawback ये होगा, it will lead to wastage of CPU cycles. Wastage of CPU cycles. And bounded waiting condition may not be guaranteed. That may lead to starvation. So atomic. Mohan, please understand, atomic means no preemption. While we are executing, basically the process, right? The semaphore, while we are executing this statement, the preemption of the process does not happen. That is the meaning of indivisible or atomic operations. Okay, so that's the paradigm. So now let's move on to basically understand the semaphore implementation, counting semaphore implementation in busy waiting based. In busy waiting based, or sorry, non-busy waiting mode, how semaphore operations of counting semaphore are implemented, namely down and up operations, how are they implemented? So let's understand. Here, solution to the critical section problem अभी जो हमने डिस्कस किया वो ये है, देखिएगा, critical semaphore mutex initialized to 1. Mutex का शॉर्ट फॉर्म है mutual exclusion, simply call wait on mutex critical section signal mutex. और एक भी एप्लीकेशन दिखाया गया है यहाँ पर, how semaphore can be used to meet the requirements of synchronization. जैसे कि यहाँ पे देखिएगा, this is second example. It is a very good example. Consider P1 and P2. There are two processes that with two statements S1 and S2, and the requirement is that S1 to happen before S2. ठीक है? तो S1 and S2 are two statements in P1 and P2, boys and girls. P1 में, process P1 में statement है S1, process P2 में एक statement है S2, एक statement है S2. ठीक है? So we are putting a condition that S1 to happen before S2. S1 should execute before S2. अगर फर्ज करो, if we don't write or if we don't use any semaphore, and if I write S1 and S2 and both are concurrent processes, then any statement can execute first, either S1 and S2. What I want, first S1 should be completed and then S2 should be completed. That means even if I start P2 first, it should not execute S2. Somehow I should block S2. I should block P2. Then enforcing P1 to complete. How can we solve it using semaphore? Very simple approach. So look at that. So in P1, I will write S1 because this is to be executed unconditionally. So after S1, then you say P2. Before S2, I am using wait on sync. Sync is a synchronization. A sync is a semaphore variable. Wait on sync. Just wait on sync. Right? This will basically, and sync will be initialized to 0. Look at this. तो इससे क्या होगा? Value of semaphore is equal to 0. It keeps on waiting. It keeps on waiting. That busy waiting, it keeps on waiting. Then control comes to P1, maybe P1 execute S1. So we are not executing S2, we are waiting here. Control comes to P1, P1 execute S1. जब S1 complete हो जाएगा, तो हम क्या करेंगे? Signal. Now S2 can execute. So therefore the signal operation will hit this wait and then we come out and execute S2. So that's one simple example or second example to prove how synchronization requirements can be satisfied, right? Among the processes using semaphore. This is solving the critical section problem. Solution to the critical section problem जो अभी मैंने आपको दिया था. So using mutex variable, हमने S कहा, यहाँ पे mutex है initialized to 1. So if I use, I can solve critical section problem. So semaphores can be used for solving critical section problem and meeting all other requirements of the problem. Now the question is, how do we basically implement? So अब देखिएगा, semaphore implementation with no busy waiting, ये स्टार टॉपिक है. This is a star topic. ये काफी ज्यादा इंपॉर्टेंट है. उसके ड्रॉबैक मैंने कहा आपको, नॉन बिजी वेटिंग इंप्लीमेंटेशन के ड्रॉबैक ये है कि इट विल वेस्ट CPU cycles and it may lead to dissatisfaction of bounded waiting. So therefore this implementation with no busy waiting, that is no busy waiting का मतलब है blocking. So blocking mechanism will not lead to bounded waiting or wastage of CPU time. So यहाँ पर इसका जो implementation है, two operations हम लेंगे, block operation and wake up operation, to basically coordinate the processes for blocking and for waking up. How? We will see first. So पहले हमें define करना होगा एक semaphore data type. So here the definition of semaphore data type as an ADT is given. We are using, because you're all programmers of C, I'm assuming that you know what is the meaning of type def. The word type def is used in C language, C++, to create a data type. So that data type is a structure and we are naming that data type as semaphore. So it has two member fields. One is value. ये member field value में we are holding the current value of semaphore. The current value of semaphore होगी वो यहाँ पर होगी. And then second is a link. यहाँ पे लिखूंगा इसका comment. This is a linked list. Sorry. What is this list? This list is a linked list. Linked list of the processes that get blocked while performing down operation or wait operation unsuccessfully. देखिएगा मैंने कहा था while performing down operation a process may be either successful or unsuccessful. So down operation का result ये होगा कि process performing down would either be successful or unsuccessful. If it is successful, it will return from down. If it is unsuccessful, it will get blocked होगा through block operation. So when the process get blocked, आपने पढ़ा है block operation, when the process get blocked, it will be added to a block queue. एक queue रहेगी separate. वो queue क्या है? वो queue semaphore की definition में है queue. This is the queue. So it will contain linked list of the processes. Process मतलब representative of process. Representative of process क्या है? PCB है. Process control block. So it is actually a linked list of PCBs that are waiting on that down operation or that semaphore being unsuccessful operation. तो कोई process down operation carry out किया और unsuccessful हुआ, then its PCB will be added into this queue associated with the semaphore and the process will get blocked. ये है the structure of semaphore. It has a value and a linked list. So every semaphore that you define, every counting semaphore, binary semaphore that you define with this structure, it will always be basically associated with a queue, which will contain the list of processes that get blocked while performing down operation unsuccessfully on that semaphore. Example लेने से और clarity बढ़ेगी. So let's have the definition of, after defining counting semaphore, we will see the definition of wait operation and signal operation. So please have a look. The wait operation क्या करेगा? इससे पहले मैं फिर वही कहूंगा. Suppose for example you have defined a variable. I am writing in caps. You have defined a semaphore variable which I have defined just here. Based on this definition, I am defining a variable semaphore. Say S. Then I should initialize the value of semaphore again. S dot value. Maybe I initialize it to 1. Something like this. फिर उसके बाद आप ऑपरेशन परफॉर्म करोगे डाउन या वेट जो भी हो ऑन एस. Then this will be my next statement like this. So I'm going to make you understand now what happens when a process perform wait operation, down operation on this counting semaphore defined in a non-busy waiting, that is blocking construct. Please have a look. सबसे पहले यहाँ पे थोड़ा अलग है than the definition what we have seen for busy waiting. तो busy waiting और non-busy waiting में थोड़ा फर्क है. Please have a look. Present value. When a process perform down operation on semaphore, it will result in decrementing the current value of semaphore by 1. सबसे पहले decrement होगा. वहां पर busy waiting में first we test the condition, then decrement. Total opposite है, boys and girls. In busy waiting, first we test the condition while s is less than or equal to 0, busy wait. Then if the condition fails, then I decrement the value of semaphore. That's how it works. लेकिन यहां पर busy wait, non-busy waiting, blocking mode में first we decrement. जो भी value है semaphore की भी decrement. S dot value is decremented by 1. Check it. S dot value is decremented by 1 because this is a pointer of that type. So arrow operator. S arrow value is decremented by 1. Means value of semaphore is decremented by 1. इसके बाद हम check करेंगे. इसके बाद whether the process was successful or unsuccessful. If the resultant value is less than 0, not even equal, less than 0. अगर equal हो then also successful. The resultant value if it is greater than or equal to 0, then the process is successful. नहीं, अगर if the value resultant value after decrementation is less than 0, then that process performing down operation is unsuccessful. तो हम क्या करना है? So we are adding this process. मतलब process की PCB कहां पर ऐड करेंगे? ये लिस्ट में ऐड करेंगे. S arrow list, ये लिस्ट में ऐड कर देंगे PCB. And what should I do to the process? I should execute a routine by name block which will cause the process to leave the CPU and get blocked. So I'm calling a procedure called block. हमने यहाँ कहा था, remember, two operations are used. Block place the process involving the operation on the appropriate waiting queue. ये waiting queue है. It will place the process. That operation will place the process. And block. That's it. ये है. This is down operation. तो फिर से summarize कर रहा हूँ down operation का. समझ लीजिएगा. Any process performing down operation on blocking construct, blocking semaphore, will first decrement the current value of semaphore by 1. After decrementation, the result may either be successful or unsuccessful. If the resultant value is less than 0, unsuccess. If the value is greater than or equal to 0, success. देखेंगे, अंडरस्टैंड करेंगे. अगर मेरा सेमाफोर क्रिटिकल सेक्शन का प्रॉब्लम है, हाउ इट इज गोइंग टू बी सॉल्व विद दिस ऑपरेशन ऑफ वेट. ये कैसे सॉल्व होगा देखिएगा यहां पर. ठीक है. So I will take same example. The value of semaphore is 1. I have 3 processes P1, P2, P3. Please see how it works. Please see how it works. P1 starts. Perform wait on S as per this logic. It will decrement the value of semaphore by 1. Value becomes 0. 0 is success. 0 is success here because for unsuccess it should be less than 0. 0 is success. Process P1 returns from down, right? And go to critical section. While P1 is in critical section, P2 tries. P2 will decrement the, P2 also execute wait on S. Decrement the value of semaphore by 1. Value become -1. Now condition is true. Add this process to the list L. So imagine the list L is here, boys and girls. The list L is here. This is a list L, block QL. This is a block QL. This is block Q. So P2 gets added here. While P1 is in critical section, P2 gets added here. Then you start with P3. P3 will also decrement the value of semaphore by 1, -2. And then that condition is also true. So add this process, P3 also get blocked. So that's how the process will get blocked and guaranteeing mutual exclusion so far. लेकिन अब देखिएगा, when P1 comes out from critical section, how it is going to guarantee bounded weight. Please observe how it is going to guarantee bounded weight. Imagine P1 comes out from critical section and perform up operation in the exit section, up operation or signal operation. Signal on S. देखेंगे logic. So right now what is the value of semaphore? Please remember the value of semaphore is -2. -2 का मतलब ये है कि there are 2 block processes. Boys and girls, there are 2 block processes. So now when a process perform up operation, क्या करेगा? सबसे पहले आपका देखिएगा, डिक्रीमेंट मतलब डाउन मींस डिक्रीमेंट, अप मींस इंक्रीमेंट. तो पहले वैल्यू इंक्रीमेंट होगी. प्रोसेस P1 परफॉर्मिंग अप ऑपरेशन. हु इज परफॉर्मिंग अप ऑपरेशन? बॉयज एंड गर्ल्स, प्लीज रिमेंबर P1. तो P1 विल इंक्रीमेंट द वैल्यू ऑफ सेमाफोर फर्स्ट बाय 1. वैल्यू बिकम -1. मतलब 2 ब्लॉक प्रोसेस है, उसमें से एक को अनब्लॉक करेगा, फिर उसके बाद एक प्रोसेस और रहेगा. ये मतलब है इसका. तो चेक करिए, इज द वैल्यू स्टिल लेस देन और इक्वल टू 0? हाँ सर, लेस देन और इक्वल टू 0, -1. So remove a process from the list and wake up. So P1 is removing P2 indirectly and P2 will go back to ready queue and come out from down operation and enter critical section. मतलब जो process wake up हो रहा है from the list L, invariably, indirectly we say it is going into critical section. Pushed by P1. P2 is pushed by P1, right, into critical section. So P2 फिर से down operation start नहीं करेगा. It is coming out from block. यहाँ से जब आएगा तो it is coming out from wait operation. So it will go into critical section. क्योंकि after wait, what do I have next? Critical section. So we say that P1 has woken up P2. And P1 say I'm leaving. Then after some time, P2 also completes critical section and performs signal operation. देखेंगे signal operation से क्या होगा? P2 also increment the value of semaphore by 1. It becomes 0. Value becomes 0. Right? Value of the semaphore becomes 0. Condition is true. हाँ सर true है. देखिए less than or equal to 0. Mean there is one block process. I am waking up. उसके बाद कोई block process नहीं रहेगा. So remove a process P from the list. Who is there? P3 is there. So P2 removes P3 and push P3 into critical section. So P3 goes to critical section. ठीक है? So P3 will go into critical section. And finally, when P3 complete critical section, it will also perform up operation, incrementing the value of semaphore by 1. Value become 1. Condition is false. S value is less than or equal to 0. No, S is greater than 0. So I don't have to remove anything because there is no block process. So I come out. And we say that all the 3 processes have entered critical section in order P1, then P2, then P3 without any problem. And I got back original value of semaphore 1. Original value of semaphore, I got it. ये है semaphore down and up operation in blocking mode. इसका advantage ये है कि generally when we are saying that this is a queue, remember this. When I say this is a queue, this is a list of processes, a queue. Generally queue follow FIFO discipline. तो जब FIFO discipline follow होगी, तो जिस order में processes block हुए थे वही order में आएंगे. तो मतलब it will never have the problem of starvation. it will never have the problem. हाँ, अगर आप LIFO queue लोगे तो then I will have a problem. So this queue is a FIFO queue. First P2 got blocked, so P2 will enter, then P3, then P4. Then I will never have starvation. I hope you get my point. Suppose if you follow LIFO discipline or priority discipline, then definitely I may have starvation again with blocking construct. So boys and girls, this is the simple definition of counting semaphore with operations down and up, wait and signal, P and B. एक सिंपल क्वेश्चन लेंगे तो क्रिटिकल सेक्शन प्रॉब्लम आई हैव डेमोन्स्ट्रेटेड हाउ इट कैन बी सॉल्व्ड यूजिंग बोथ काउंटिंग एज यूजिंग बोथ ब्लॉकिंग एंड नॉन ब्लॉकिंग. अब टर्न है टू टेक अप वन सिंपल प्रॉब्लम व्हिच वाज आस्क्ड इन अर्लियर पेपर ऑफ गेट इन मेनी टाइम्स. द क्वेश्चन इज समथिंग लाइक दिस. प्लीज सी. एक सर्टेन एप्लीकेशन में आई हैव सेमाफोर. आई एम राइटिंग इन शॉर्ट से S. द इनिशियल वैल्यू ऑफ सेमाफोर इज 4 एंड वी कैरी आउट द फॉलोइंग ऑपरेशंस इन दिस ऑर्डर. क्या ऑर्डर है? लेट अस से आई कैरी आउट 10 डाउन. P मीन्स डाउन, एंड देन आई कैरी आउट 3 अप. V मीन्स अप, एंड देन आई कैरी आउट 15 डाउन, एंड देन 4 अप, एंड देन आई कैरी आउट 6 डाउन, एंड देन आई से फॉर एग्जांपल 8 up operations in this order. I carry out first 10 down, 3 up, 15 down, 4 up, 6 down, 8 up. These operations were carried out by the process. Now the question is, ऐसे question 3-4 बार आ चुके हैं previous papers of GATE. So please follow. Question is, what is the current value of semaphore? What is the current value of semaphore? क्या आप बता सकते हो कोई चैट बॉक्स में what is the current value of semaphore after all these operations are completed? After all these operations are completed, can anybody tell me what is the current value of semaphore? What is the current value of semaphore after all these operations are completed? After all these operations are completed, what is the current value of semaphore? Come on, boys and girls. Any idea? Vijay is saying answer is 0. Is it 0, Vijay? Mohan is saying -12, which is correct. Mohan, I saw your comment just now. What weight is atomic? So if P2 is stuck in the while loop, see, it's very clear. If P2 is stuck in the while loop, no problem, right? When the time quantum of P2 gets over, for example, then automatically it will be released from the CPU and given the chance to other process. It got mode shifted. जब mode shifting होगा तो P2 is out of CPU, right? Out of CPU. So therefore, there is no problem at all. P2 is no more on CPU. I hope you got my point. So what is the current value? Let us solve this question, boys and girls. Have a look on board. Have a look on board. The value of semaphore is 4. We are performing 10 down operations. अगर हम एक डाउन ऑपरेशन परफॉर्म करेंगे तो वैल्यू डिक्रीमेंट होगी बाय 1. 2 डाउन ऑपरेशन करोगे तो दो बार डिक्रीमेंट होगी, डिक्रीमेंट बाय 2. 10 डाउन विल मेक द वैल्यू ऑफ सेमाफोर टू हाउ मच? बोलिएगा, -6. -6 होगी, करेक्ट. 1 डाउन विल डिक्रीमेंट बाय 1, 3, then 2, then 1, then 0, then -1, उस तरह -6 हो जाएगी. Now when I perform 1 up operation, value gets incremented. When 3 up operation perform करने से value become -3. Then I carry out 15 down. 15 डाउन के सारे डिक्रीमेंट हो जाएंगे, -3 to -4 -5 15 टाइम्स, तो 15 ऐड कीजिएगा, इट विल कम -18 -18 से 4 अप ऑपरेशंस करने से 4 टाइम इंक्रीमेंट होगी, +4 मतलब -14 फिर उसके बाद 6 डाउन, then all 6 will be added to this, making the count to -20 and then -20 से 8 अप ऑपरेशन करोगे आप, तो इट बिकम 8 टाइम्स इंक्रीमेंट करोगे, +8 -12. So what Mohan has said is absolutely correct. The value become -12. It become -12. ठीक है? I hope you understood. So final value of semaphore is -12. So like that the question can be asked reverse way. I may not give the initial value, I perform the operations, और मैं बोल सकता हूं कि the final value of semaphore is this much. The final value of semaphore is this much. And then basically you can be asked what was the initial value of semaphore. इस तरह के क्वेश्चंस आएंगे. कुछ और क्वेश्चंस मैं नेक्स्ट सेशन में लेके आऊंगा, क्योंकि आज का सेशन ऑलमोस्ट 1 hour we completed the target. So next session I will take up some more PYQs on semaphore, and then I will take up the applications of semaphore in the form of classical IPC problems like solving producer-consumer problem, reader-writer problem, dining philosopher problem, using applications of semaphore as applications of semaphore. This we will discuss in the next session. Okay? So take care. Thank you. Happy weekend, and continue your process, or the persistence of learning process and the hard work. Okay? Take care. Thank you so much. Good day.